This video will look at how to solve a quadratic problem, and we'll focus on factored form with this one. In this case, we have the height of a ball h, so h represents the height, can be modeled by the equation below, and in this equation, x represents the time since the ball was launched. So here's the equation. We know it's a quadratic because it has an x squared term, and we know that it opens down because it has a negative a value. So I don't know what this looks like, but let's assume it looks something like this. First question is asking at what time does the ball hit the ground? Well, that's really asking when is the height 0, and if we look at this graph, our height is represented on our y-axis, and our time is on the x-axis. So the ball hits the ground at these two locations, and we need to ask ourselves, what is the height at those locations? Well, we haven't gone up or down, so our height here is 0. So nice little tip here to help out is that h equals 0 for this scenario. So let's go ahead and do this. What time does the ball hit the ground? We need to figure out the zeros of this function or this relationship, and we do that by setting h equal to 0. So let's go ahead and do that. 0 equals negative 5x squared plus 10x And in order to find the zeros, we're going to use the zero product property. So we want to factor this because we'll know that one factor times another factor will equal 0, and we can set the factors equal to 0. Before we do that, though, notice that each term here is divisible by 5. So we'll go ahead and we'll actually common factor out a 5. And in this case, we're going to factor out a negative 5 just to make things a little bit easier for us. So I'm going to, from an area model perspective, that will look something like this. So we have our negative 5x squared, have our positive 10x, and we have our, whoa, I wrote a 5 here, that should be 15, positive 15. So as we said, there's a negative 5 that's common to all three of those terms, so we'll factor it out. Negative 5 times what value up here, it has to give us negative 5x squared. This will have to be an x squared. Negative 5 times what value up here has to give us a 10x. So negative 5 times negative 2. Be careful of the sign there. Negative times a negative will give us that positive. And lastly, negative 5 times what value will give us positive 15. So just be careful here. Negative 5 times negative 3 will give you positive 15. So our equation then becomes 0 equals negative 5 times x squared minus 2x minus 3. And now we're going to factor the trinomial. So this is a trinomial, has an x squared term, an x term, and a constant term, and we can factor that using an area model. We could use the rectangle tool to get a better rectangle, but this might be a little faster. All right, so we'll stick the x squared in the top right, we'll stick the minus 3 in the bottom left, and again, the diagonals here have to give you the same product. So this diagonal here is negative 3x squared, which means that the other diagonal also needs to be 3x squared, but they have to add to negative 2x. So obviously there's an x in each of them. The only things that multiply to 3 are 1 and 3, and we need a a sum of negative 2, which means that this will be a negative 3, and this will be a positive 1. You can write the 1 in there, or you can leave it out, doesn't matter. At this point, we're going to common factor, I'm going to common factor the first row, so there's an x common to both there. In order to get the x squared in the first, in the top left, we'll need an x as well. So x times x will give us x squared, x times what will give us negative 3x, so that's going to be a negative 3, and finally down here, x here times what value here, will give us a positive 1x, and that's just going to be a plus 1. And again, we can just double check. X times x is x squared, x times negative 3 is negative 3x, 1 times x is 1x, and 1 times negative 3 is negative 3. So our quadratic factored looks something like this. X plus 1 and an x minus 3. Again, just reminder that the order here doesn't matter. I could have written the minus 3 first and the plus 1 second. Doesn't really matter. All right, so now we have this factored quadratic, and in order for a quadratic to equal 0, one of the factors has to equal 0. And if we look at this scenario here, you can see that, well, this is a factor here. Negative 5 can never equal 0, so we don't need to worry about that one. So let's look at this one right here, x plus 1. And you can probably do that one just by looking at it, but just in case you can't, we're really trying to solve this right here. It's x plus 1 equals 0. And so we subtract 1 from both sides, and we'll get x equals negative 1. Same thing over here. We know that x minus 3 has to equal 0. We want to solve for x. We undo the subtraction by 3 by adding 3 to both sides. So we'll get x equals 3. So there are our two zeros, which tells us, I'll just add that to the graph. Maybe we'll get rid of the graph that we made over here as a rough guide, and we'll just add those zeros in. So we know that there is a 0 at positive 3, so 1, 2, and 3. And we also know there's a 0 at negative 1. So that's a parabola, it opens down. Let's move on to part B. Part B asks us for what is the maximum height reached by the ball. So the maximum height is really just asking for the vertex. And the vertex of the quadratic has to happen halfway between the two x-intercepts. So the x-coordinate is going to equal, of the vertex, is going to equal the midpoint of the two zeros, or x-intercepts. So we just add those two and divide by 2. That's how we find where the middle is. So negative 1 plus 3 is negative 2. Negative 2 divided by 2 is 2. So we know that the vertex happens when x equals 2. And then to find out actually how high it gets, we just substitute that x equals 2 back into either the original equation or our factored form. It actually doesn't matter which form we go into. Whatever you think is going to be easiest. So we could go into this form right here, or you could go right in from the original question. Either will get you the same answer, and it's kind of a matter of preference. Sometimes the numbers will be easier to work with in one. I'm going to go into factored form here, just because that's what we've been working with. So we want to figure out what is the y value when x equals 2. So substitute a 2 in, so we get x plus 2, sorry, not x plus 2. Let's try that one more time. We have negative 5. We're substituting a positive 2 in for x, so everywhere there's an x, we're going to replace it with a 2. So we're going to do 2 plus 1 times 2 minus 3. Do the brackets first. 2 plus 1 is 3, 2 minus 1 is negative 1. And if we do this correctly, we should get, what's that, 15? 15 being somewhere up here. We said x equals 2. Sorry, we said x, oh, hang on a second. I wrote x equals 2. That should have been 1. Negative 1 plus 3 is 2. Divided by 2, that should have been negative 1. Let's fix that up quickly. X equals 1 is our midpoint. And I caught my error because looking at the graph, I could see that 2 was certainly not in the middle of the graph. So let me just fix up a little bit here. Substitute a 1 into our equation, which actually might make the math a little easier, maybe. 1 and 1 minus 3. All right, here we go. 1 plus 1 is 2. Negative 5 times 2. And 1 minus 3 is negative 2. Negative 5 times 2 is negative 10. Negative 10 times negative 2 will give us positive 20. That tells us that when x equals 1, right along here, right in the middle, right along our axis, is our axis. I won't draw all of it. So x in that case is equal to 20. And I don't quite have room on my graph. Let's pull that down a little bit so we can see it. There we go. There we go. Clean up our picture here to match. So we had an x-intercept at -1, an x-intercept at 3, 2, 3, and our axis, do this with an actual line this time, is right along this line here at x equals 1. That's not a very straight line, is it? Try this here. Alright, so there's our axis. The equation of our axis is x equals 1, and we know that y is equal to 20, or h, I suppose, in this case, is equal to 20 at that point. So there's our vertex, and we could see that if we were to try to draw this parabola, forgive my wavy hand here, going up all this distance, but it'll look something like this. Oh, I missed the top. Okay, so it looks something like that. Poor sketch there. So what is the maximum height? The maximum height reached by the ball is 20. And, well, I didn't give you units in the question, but we'll assume that's in meters. So say here, 20 meters. Therefore, the height, max height, part C is asking when is that height reached? Well, that's the time, that's this value right here, and that happened when x equals 1. So maximum height reached and x equals 1. So after 1 second. And then the next question, at what height was the ball thrown from? Ball is thrown, sorry, this is where my graph doesn't quite look great, but the ball is thrown at time equals 0. That's when we start measuring the height, is when the time equals 0. So in order to figure out that value, we're just going to set x equal to 0. Again, we can do that 2 ways, and maybe I'll just show you both ways. The first one is we could actually substitute into the original equation. So h equals -5 times 0 squared plus 10 times 0 plus 15. And I chose that one first because the math here is really easy. When I substitute 0 in for x, the 2 terms with zeros in them disappear, and we get an h value of, well, 0 plus 0 is 0, and then we add 15, so we get a height of 15. So had my graph been precise, we would have gone through that point right there. So really, when it's asking what height is the ball thrown from, it's asking for the y-intercept, or in this case, the h-intercept. So I did that using the standard form, but we could have used factored form as well. Factored form way back over here. So we would just say that h is equal to -5 times 0 plus 1 times 0 minus 3. Hopefully we get the same answer here. 0 plus 1 is 1. 0 times -3 is -3. And then 5 times -5 times 1 is -5 times -3 gives us 15. So either way works there. Whatever you're most comfortable with, I think standard form is easiest if you have it. I mean, if the equation was given in factored form, you're going to have to use this second model unless you wanted to expand, but that seems to be a little more work. So that's how we can use quadratics to find some different points or values about this situation. This question didn't ask it, but it could ask how long was the ball in the air for? Well, the ball was in the air for this time right here, was launched right here, and it landed right here. So we just need to figure out the difference in time between those two things. And because we started at 0 and finished at 3 seconds, it was in the air for 3 seconds. So hopefully that helps.